it's a great pleasure to come to TERRA to give a talk. I see what I'm going to say or present to you as something that sits alongside the seed's mission and philosophy. It's not in that philosophy, it's sitting alongside it. And my thesis is that a time has now come where some of the innovative energy that we are seeing in the work that SEED is doing, or many other such organizations are doing, using what we call traditional materials with new scientific know-how to serve contemporary needs, generally in the small town and rural situations. Generally they're doing that. And now the time has come to look at what the world is going to move towards inevitably, which is a lot of people living in cities. And just trying to see how this kind of thinking or this approach to the issues that confront us can be integrated into this new world that is coming upon us. So the title is Sustainable Urban Communities, Challenges and Opportunities, and this kind of picture is now quite familiar to people who are living in cities like Delhi. Most of us know this, but it's worth just recounting the story once again. In 2011, there are 3 cities with population greater than 10 million and 53 cities with population greater than 1 million. And over 833 million Indians live in 0.64 million villages, but 377 million live in about 8,000 urban centers. That's what we see today. It is predicted that by 2031, there will be 6 cities with populations more than 10 million. And a key question is how many would live in medium and small towns and bridge between the transforming rural and urban India. It's quite clear the way the developmental juggernaut is moving, and with growing populations, this is going to be the form of life for a majority of us, say by the middle of the present century. And so we have to pay attention to that. And that form of living in high density concentrations is the form that is inherently a burden on the natural environment. That form of living is inherently a burden on the natural environment, and we have to pay attention to that. Demand for housing, here's a prediction. That most of the demand for housing is going to come from the low income and middle income segments of society. It is this section of our society that is not being adequately addressed by the formal market or the formal provision of housing at the moment. Although there's a shift in this direction now as the upper income housing is getting sort of saturated. And I think that is looking at simple homes for simple lives, not high-end homes for expensive and highly consumptive life, is the zone where a lot of us are going to find our mission to be fulfilled. These are the pictures we are familiar with of the way, the form this housing is already taking. And this is to do with land economics and politics and the business model that developers follow, etc. But this is becoming the tendency of the cities to live in this kind of building. And this is you can see this happening even in the small and medium towns. At the top end, these are pictures of new builds. At the bottom, it is the city regenerating. In this case, it's Mumbai. So what was tenements 1 or 2 stories high, tightly hugging the ground, because of the pressure of land values, are being now squeezed into 11, 12-story tenements sitting beside luxury apartments. So that's the pattern in which the cities are moving. So apart from the fact of building in this very inhuman and inappropriate way as we grow, as the cities develop, there are two other things that are happening in our cities, and these have serious implications. That more and more people, as they move into the middle class, are looking for higher levels of comfort in their homes, because you are accustomed to that when you go to the cinema, when you go to the restaurant, when you go to the hotel, even when you go to college nowadays, or you go for a performance anywhere, you are accustomed to that. Even in your car, you're accustomed to that. So you're beginning to look for much higher levels of comfort at home. And air conditioning is a big issue for us. And similarly, as you save a bit of money, you want your own freedom of movement, and you want to buy yourself a private vehicle. And these two are the two things that are going to run us underground very soon. Well, that nano appeared and it disappeared. If you were to assume that a small proportion of middle-income homes were to come into air-conditioned space, in the next 5 years, if you follow the prediction of 20 million dwelling units being built, we will have an 18,000 megawatts of additional summer peak load because of such building. All right? So you can see that there's a real huge pressure on carbon dioxide emissions and the demand for energy attributable to a changing lifestyle looking for higher levels of thermal comfort. And in a survey that was done a year and a half back here, we actually were able to establish with data that the rise in the consumption of electricity in the homes, or a substantial rise in the consumption of electricity in the homes, is directly attributable to moving into air conditioning. So we have to see how we design for comfort without getting into air conditioning or conventional air conditioning. The other thing is that when you build so much and so fast, and if you build in ways that you build in cities, which is sometimes large span, RCC frame, tall buildings which have to resist the earthquake as well as the wind loads, and so on and so forth, and you have to meet all kinds of fire and safety codes. When you build like that, in comparison to traditional building in the small towns and the village, the building itself is inherently much more energy consumptive in its materials of construction. All right? And if you say that you're going to add 50% of the built space to your existing stock very soon in the next 10 years, and you multiply it by another 50% increase in the embodied energy per unit area of floor space that is produced, and you do that over 63 cities of 1 million plus, okay, what do you have? And you compress that in a decade, you can have an explosion of carbon dioxide emissions on our hands. So just the fact of building so much at such a rapid pace is a problem in itself. And building in cities in the manner that we do build today is the next big problem. Now, at a rough estimate, it is possible to bring down carbon dioxide emissions in the construction of buildings by at least 18 or maybe even 25% if you are truly creative. And it is simply saying that if you were to adopt alternative materials and techniques of building in cities, rather than saying that we're not going to build in cities, we're going to build in villages because that's inevitable, you're going to build in cities, you can, as compared to building as usual, substantially replace existing highly consumptive methods of construction with more sustainable methods of construction and materials and reduce the impact of embodied energy. Here too, we did some actual calculations looking at buildings that have been built, and we did an analysis of the embodied energy in these buildings, and looking at only the structural systems and the external walls, we found that if you give preference to low-rise buildings, G+4 in residential development, and use low embodied energy materials for external walling and for structural systems, you can potentially bring down the embodied energy by anything between 20 to 40% compared to building as usual. So it's now if you go back to the motor car, for instance, one of the things about mobility is that you have to, if you want to reduce the desire or the need for mobility, you have to build compact. The cities have to be compact, they have to be relatively small, they have to be compact, which means somewhat higher densities. And that is one of the reasons why things are going 10, 15, 20 stories high. But what we found is that you can build fairly high density at 4 to 5 stories, and now that also enables you to use different kinds of construction techniques compared with the standard RCC frame and so on. In the international discourse on the energy consumption in buildings, it is often argued that embodied energy is of no consequence, but what is of real consequence is the operational energy used in buildings. But that's not so true in our case. In a case where there's an explosion of construction, there's growing population, and you've got a window of opportunity of just this decade within which you have to reverse the trend in the increasing consumption of energy and reduce your carbon footprint. Because in simple buildings, even today, it is only at about the 9th year, according to this diagram, that the operational energy reaches equivalent to the embodied energy invested in the building at the start. So it's really very important to pay special attention to embodied energy. Now I'll just go over a few examples of what some of the strategies can be. Even when you're building in suburban or rural contexts, I think it's very important, as our old villages always were, build in very compact formations. Even when you're building for contemporary needs, build in compact formations, not to spread the buildings out, but to bring them as compact as possible. So in this particular case, where people wanted housing for industrial workers, they had actually allocated this entire zone for residential things. And what they imagined was there'll be bungalow, 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 road, 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 car, 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 and all of that. That's what they imagined. But what we found is that this is all you need to build. That's all you needed to build for all your needs. And you can return everything else back to agriculture and forestry. And then, of course, the idea is that building compact also enables you to integrate all kinds of environmental systems. We won't go into that just now. Even if you're building very simply, in this case it was 2-story houses, one of the opportunities we have is to think of how the fabric of the building itself and its structural mass interacts with its thermal behavior, and to design the structural mass of the building and make it interact with the cool evening or the cool night air or evaporative cooling, because we do cooling most of the year round in most parts of the country. Use that system as a way of obtaining cools during the daytime and during the summer seasons, rather than to rely on alternative strategies of mechanical or electromechanical systems. And so here is an opportunity of using hollow walls and hollow floors through which cool air moves. And here's a sample house that was built. Hollow floors and hollow walls through which cool air moves to actually cool down the entire mass that envelops you in your room through the day, through the night, and then keep the building protected during the daytime. So this requires a new way of building and understanding the science of the building physics, of the thermodynamics of the behavior of the structure. Another important issue as we come into the middle class home, and we happen to be working with a developer for low income housing right now, is that going out and doing the surveys and asking people is that the urban culture is an aspirational culture. Everybody is looking for a better kind of living. and everybody is looking for change. They are not looking for carrying forward their old ways, they are looking for new ways of living. And interestingly, the middle class home with its kitchen and its toilet and a place around the TV set, a separate room for the parents and another room for the children, is fast becoming the norm, no matter which section of society you believe in, you are in. And that seems to be now, that's becoming the norm, and it's becoming the aspirational norm, all right? And so I think even as one designs the new home, especially in the urban context, with swift changes that are occurring, one has to understand the aspirational aspects of lifestyle. And building in cities for lots of people together has a very long-term implication. A building that is built today is going to last over a long period of time. And if it is going to be affordable today, it shouldn't be such that it is a poor building tomorrow. It has to be such that it is even a better building tomorrow. And so, a theoretical model, what makes housing? At the first level, people are looking for durability, functionality, cost, timely delivery, extremely important, especially if you are borrowing money. If I am borrowing money to pay a deposit, you better deliver the building within 10 months or 11 months. Otherwise, it's a cost on me, because I'll pay not only the rent that I'm spending today, I'm also paying the interest on the money that I borrowed. Time is extremely important. That is then multiplied by that system being able to respond to different requirements of size, room layout, different kinds of components to be added, finishes to be changed, responsiveness to different kinds of climate, or adjustment to the building and improvement of the building from its climate response point of view, and also a response to the site. And so if this is what is within the building, when you put it together with other things, mobility, water, electricity, waste, combined with leisure, commerce, community, education and health, and this also as a system being adaptable and robust for the future, is what is actually required. You may need to have somewhat standardized modes of building if you're going to build quickly. Somewhat standardized, just like, I mean, in Ladakh it's somewhat standardized mode of building, but within that there is a lot of variation that's possible. So the same philosophy goes, but it must anticipate the lifestyle changes as buyers become middle class and form a community. It must be adaptable to respond to different climatic conditions also. Right. So you may have a preferred mode of building because it is very convenient, but it must be so versatile that you can adapt it for different climatic situations. Well, and you have to take it very seriously. Why? Remember air conditioning. If you don't take thermal comfort seriously, the moment I get back into my house, I'll simply press the button of the air conditioner. And I'll have undone all the good work that I've done before. So I've got to take this extremely seriously. I've got to make sure that whatever the mode of building I've chosen, it has been adapted effectively to use all passive strategies possible to minimize the dependence on electromechanical means for obtaining higher levels of comfort. And this is what we found. It was very interesting. On the outskirts of a big metropolitan area, if you build 4 to 5 stories high in compact formation, you can actually achieve pretty much, you can achieve an economically viable model, something, you can afford the price of land, you can afford the type of house, you don't have to spend on lifts, you don't have to spend on pumping the water up, and you get a lot of people living together sharing a lot of facilities. We'll see about that a little later. And so you get a dense urban fabric, but it is about 4 stories high. Now here's a very interesting finding, that you can almost adopt a standardized bay, all right, which means these are standard spans. So if you're using formwork or shuttering or whatever, it can be very simple, and it can be, so your investment in the tools and equipment that is required for construction can be very small, and you can run it as a load-bearing system up to 4 stories high. Now here's a challenge. You can run it as a load-bearing system 4 stories high, but if you are using, which is what we wanted to do, but we haven't been, we were not convinced, we were not able to do it. Eventually this has come out to be concrete with very, very high fly ash content, up to 57% fly ash content. But what we would have loved to do is to do rammed earth, 25 centimeters thick, and if it needs some reinforcement somewhere, build up to 4 stories high with this. And within this, there are openings that are left so that you can actually begin to combine the spaces. You can make an opening and combine into the next house. All right? So adaptability, extendability, modification of the internal layout, and a structural system which is environmentally friendly are possibilities, but it does require some careful working out. We will have to be, we were talking about embodied energy to start with, but we do have to look at operational energy later on. Consumption of electricity must be disciplined. There is a limitation to the size of electrical connection that a house is permitted, but it is worked out such that all your conveniences can be powered with this much connection. And there would be a policy for, well, each house is of course metered, and similarly water supply would be equally metered. And you would work, this is the aspirational kitchen. It will be progressively you will want to reach a stage in life where you call yourself a middle class home. All kinds of opportunities for design of the building fabric. And when it comes to community level work, there's more opportunity. Systems on the rooftop, systems on the ground, and let's not forget one important thing here, that every city is going to regenerate and it's going to produce its own waste. And there are huge opportunities for working with waste of the city to produce new building material. There's a diagram that just explains how local waste can be recycled for different kinds of purposes. And here's just a picture of a typical home that we see everywhere, where there are any number of elements which can be fabricated and constructed out of the waste of the city. And so apart from using traditional materials, the recycling of the waste is another opportunity for innovation. It is a misconception that all technologies and methods in design integration towards low carbon future already exist, and this is what a lot of people will tell you. All the new technologies that are required exist, and then you simply have to adopt them. And also that climate conditions, lifestyles, aspirations, availability of materials and skill, and economic capacities of vast majority of citizens call for innovative solutions that are appropriate to their needs and are affordable. They don't exist today for the city's requirements. And this calls for an intensive program of research and innovation. We've seen this before, a great inspiration from Laurie Baker. We've seen this work coming along, and Orville, working with Earth. We've tried to integrate some of that thinking into buildings, modern or contemporary buildings for contemporary needs as a development alternatives. And we've seen this kind of work. But I still feel that one need not be a purist in our approach to the use of materials. It is a question of finding the opportunities for using low embodied energy and natural materials into the complex systems for urban provisions. This is an important point, that innovation should be of a simple technology, of use of scientific knowledge to make simple products to obtain enhanced environmental and functional performance, involving investment, low investment in R&D and production infrastructure. This is a system for distribution of income and of enhancing knowledge locally. So it's not only about recovering traditions, but it is using those as a platform for advancing further. I will just read the last bit here. The task before architects and urban designers designing for the developing world may be to find environmentally sustainable solutions for the built environment, which are affordable, which maintain the authenticity of evolving cultural imagination, while creating an economy of building that spreads knowledge and shares wealth. Thank you.